So remainders mean if it doesn't go evenly, we have some kind of number, right? We talked about when we divide, correct? So remainder theorem. If a polynomial function f of x is divided by something, I'm going to call it n. If it's divided by n, then, oh, don't call that n, that's stupid. Don't. Don't call that n. You're not going to divide it by n. You're going to divide it by something, right? Depends on what we divide by. Could be linear, x minus something, could be x squared, it doesn't really matter. As long as you divide it, your remainder is your function value at c. Okay? Now, here's what's nice. We're going to evaluate using synthetic division. And when I evaluate using synthetic division, your answer is called synthetic substitution. I don't really care if you know that. The reason I want to do this is you can get functions that are ridiculous to plug in, and it's easy to miss the wrong exponent, it's easy to miss the plus or minus sign. The big thing here is you're going to use synthetic division to evaluate. So, here's what you want to do. I want to know what f of -3 is. And prior to this class, you'll plug -3 and then plug and shove into your calculator, right? Just replace x with -3. Now what we can do is we can take synthetic division. Put c in my box. So then -3 in my box. I'm going to draw my line. And I have to put what? I need my coefficients in order, correct? And if I'm missing a term, I must put in a 0. So I have 1, 8, 12, -7, and -14. Yes? Just like what we did on Friday, right? Synthetic division listed out. What do I do first? Bring down that first term. Boom. Then what do I do? -3 times 1 is -3. Then what do I do? You add them. Then you're at 5. You're at -15. You're at -3. You're at 9. You're at 2. You're at -6. And you're at -20. Yes? Agree? F of 3 is -20. You plug it in. Your calculator is the exact same thing. Surprisingly, to be honest with you, this takes less time than plugging it in. It really does. Number 2, what's going to go in my box? 1's going to go in my box. Am I missing any terms? 5, 4, 3, 2, 1, 0. We're good, right? So 3, 2, 4, 3, 2, -3. What do I bring down here? Always bring down the first term, right? So I'm going to bring down 3. So this is 3, which is 5, 5, 9, 9, which is 12, which is 12, which is 14, which is 14, which is 11. Now, on your quiz on Friday, if that's the only thing you do, I will not give you credit for it. Yes, I'm going fast. You guys can just calculate if you need to. I will not give you credit for this answer. What's different between the first one and the second one? No, not necessarily. Yeah. What's different with one that I didn't? What did I do with one that I didn't do with 2? Yeah. I said, well, f of this equals this. That's what the question's asking you to do. So you would have to say f of 1 equals 11. Does that make sense? You have to answer the question, just like with synthetic division or long division. You can't just leave it up there without telling what your actual answer is. Yes? Try 3 and 4, please. All right. So 3, -2 goes in the box. Be careful on this one. You're missing your squared term, so if you don't have a 0 in there, that'll cause the issue. On that one. Are we good with that one? Okay. 4 goes in the box. I think we'll tell the other first. -2, 7, 2, 0, -1, and 8. Do I need to keep going with this one? Did you forget your 0? You forget your 0. That causes it. That's okay. These are conditional terms, right? So it's not really bad. Okay. Just remember, if you're missing a term, so it's like 5, 4, 3, 2, 1, you don't have to. You gotta put a 0 in there because it causes everything to mess up. Yes. Okay. Application problems are going to start getting really important in this class, especially when you get into conics, we do a project where you just like, hey, here's this issue with this bridge. You got to fix it using a conic. Talk about that later. So there's my equation. It says use the remainder theorem to find the number of tickets sold during the 7th game of the season. Well, how am I going to find that? What does X equal in this case? I'm talking about the 7th game. What does X equal? 7. So you need to find F of 7. How do I find F of 7? Use synthetic, yes? Are you missing any terms? 3, 2, 1, 0. We're good. So 1, the 7's in the box. 1, -14, 72, 68. How many tickets were sold in the 7th game? So drop down to 1, 7, -7, -49. What is that? 23? Right? Yeah. 23, 140, 151. Is that right? 61, thank you. And so 228, 29, 1, thank you. 229 tickets sold. That makes sense? Gives you a bunch of information, pull up the equation, find what your X value needs to be, solve it. Yes? Okay, that's remainder theorem. Check? Easy? Factor theorem. This is what factor theorem is going to look like. And we talked about factor theorem a little bit on Friday because I said, are your remainders always going to be 0? The answer is no. And when your remainder is a 0, that is a factor. Okay? This is important. If your divisor has a remainder of 0, it's a factor. That's really important. That's all we really need to know today. So, if your remainder is 0, it's a factor. This is my first equation, yes? X cubed minus 31x plus 30. I want to see if any of those are factors. You can long divide if you want. How many of you want to long divide? None of you do. You want to use synthetic. So, let's see if x plus 1 is a factor. What goes in my box? What? -1. Am I missing any terms? Yes, you're missing x squared, right? So you should have 1, 0, -31, and 30. Drop down the 1, -1, -1, 1, -30, -30. What happens? What's your remainder equal? 0. So this one is a factor. Now, you know what you can do from here? We need to test if 5 is also a factor. You can start from the original equation if you want, but you don't have to. If your first one works, you can use your now simplified to find if 5 is a factor. So what I'll do is I'll put 5 in my box, and I'll use exactly what I have here. If it's not a factor of this, it's not a factor. Bring down 1, 5, 4, 20, 50. Is 5 a factor? Guys, copy it. 5 a factor. No, you shouldn't have to look up my board to synthetically divide. I'm not trying to be mean to be not. Okay? You have to check what next. What? Oh, 2. I thought you said 2. I was what are you talking about? Yeah. It's not. It should be positive 30, so x plus 1 isn't 1 either. It should be 60. Is that what you guys were all looking at before? That one doesn't work either. Okay, hold on. Let's just pause and go back because you made a big mistake there. Where were you like 2 minutes ago there, G?
Me?
Yeah. Or I made my mistake. Okay, that's fair. 5. You gotta check 5 with the original. So 1, 0, negative 31, 30. Because the other one didn't work, so I suck. 1, 5, 5, 25, negative 6, negative 30. What's the remainder for this one? What's my remainder for this one? 0. So is x minus 5 a factor? Yes, x minus 5 is a factor. Now we gotta see if x plus 6 is a factor. So plug in negative 6, 1, 5, negative 6. 1 comes down, yes. Negative 6, negative 1, 6, and 0. So x plus 6 and x minus 5 are both factors. Does that make sense? Try 2 and try, that's it, try 2. Try 2, please. Here we go. Here's what we're going to. We're going to use the factor theorem to be able to factor because, yes, we can factor this first one by grouping. Can we factor the second one by doing anything? Not at all. Okay? So I'm not even going to do this one because you can factor that by grouping, so I actually kind of hate that combination. We're going to do the second one. When we start to talk tomorrow, you're going to actually have to find your factors first. I'm not going to always give it to you. So tomorrow I'm going to say, hey, here's my function. What are the factors? But we'll start with me giving you a factor first. What should go in the box? Negative 2. And then you're going to have 9, negative 18, negative 73, 2, and 8. Agree? What should the remainder equal? I'm telling you it's a factor. What should the remainder equal? 0, right? If it doesn't, then you got to go back and check your work. So bring down the 9. Then you have negative 18. Yes? Then you have negative 36. Correct? Then you have, what, 72? All right? Yep. You have 72. Then you have negative 1. Then you have 2. Then you have 4. Then you have negative 8. And then you have 0. Yes? Now, that's only one of my factors. How many factors could I or should I have? What's my degree of my function? 4. So I need some more factors. My degree is towards my largest exponent. So now what I need to do with this is I need to write this out as you would have written out on Friday as your answer when I divided. So remember what I said. These are your coefficients, yes? What's the variable in exponent that goes on the 9? X to the third. Just subtract it. So now I have 9x cubed minus 36x squared minus x plus 4. I'm going to set it equal to 0. Not because my remainder is 0. I'm going to set it equal to 0 because I need to find my zeros. I need to find my factors. Well, how many terms do I have? Terms. 4, right? Boom, 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 boom. 4 terms. How do I factor? Group it. Okay, what's my GCF of my first term? 9x squared, right? Then you have x minus 4. What's my GCF of my second group? Negative 1. And then you have x minus 4. equals 0. Okay? Now I gotta put the outsides together, correct? So 9x squared minus 1, x minus 4, still equals 0. Yes? Is that 100% factored? No, because how do I know if it's factored if it has the x to the what power? What has to be in that parentheses with the x? It's going to be x squared. No, it has to just be x, right? Is this the difference of two squares? Is 9 a perfect square? Is x squared a perfect square? Is 1 a perfect square? Yes. So this factors 2, 3x minus 1, 3x plus 1, x minus 4. How many factors do I need though? What's my degree of my original function? 4. How many factors do I need? 4. How many do I have written down there? 3. Where's my other one? My factor though, not my 0. My factor is x plus 2. This is the one that when we ask you to completely, when I ask you to completely factor, that's the one you will always forget. The one that is given is the one that gets forgotten every single time. Okay, just remember, look at your degree, how many factors you have written down. Does that make sense? All right, homework, I'm only giving you 6 problems. You guys have some time in here to get them done, which is nice. So come grab one, and then I will tell you which ones I want you to do.